Well, I made this workshop in the back of my garage without any consideration to acoustics, and I had it wet plastered onto masonry, and as you can hear, the acoustics are appalling. But after installing this white padding on the walls, I think it's considerably better. So far I've only installed the panels at each end, and I've got a few more panels to put up. It's interesting that although the panels only occupy the top half of the wall, they still have a dramatic effect. And I've still got a few more panels to put up on the ceiling. I dare not tell you how much this cost. Well, looking on the internet, I couldn't find a clear description of how to take the quill and spindle out of a WM18 mill. So I'm just going to do that step by step at the beginning in case somebody wants to know that. And then we'll go on to a longer saga. Step 1, undo the screws and take this plastic case off. Step 2, do up this nut, because for two reasons. You've got to press down, let me undo it first off. You've got to press down on this, and if the nut isn't done up, it just goes down. But much more important, if this nut isn't done up, when we undo this, the quill will fall out and hit the table. So make sure that's done up. Step 3, slightly loosen this nut whilst holding the spindle at the bottom. Step 4, put the spindle so that the hole in it, which signifies where the R8 taper should go in, is to the front. Then we take a screwdriver and push this black tube down. There's a point between here and here where you can press this thing down without engaging on this C-clip. So it comes out like that. Now we can just undo this nut completely and take it off. I'm just twisting the spindle at the bottom to achieve this. When it comes off, it's going to spring up a bit. Like that. Right. So we've got a kind of metal tube and a spring, which you can actually leave both of these things in there, but that's what it is. And this spring is the spring that effectively holds makes the quill go back upwards automatically. So now we can take the weight of the quill, undo this, and it just comes straight out like that. No problem. Well, I think we just have to offer this up, engage it in whatever gear is up there. And then wind it up. And what we've got to do is I don't know what the right order to do these things in is. I think I'll put the nut on first. To get the nut on, you have to press Don't do it like that. You have to press this down. Like that. And then it's quite strong, this spring. That's it. Right. So now I can just do this up gently. Right, I'm going to do it slightly loose because I've got to put this C clip in. There we go. That's it. Let me do this up so it won't go up any. I don't know what's stopping this going on. Maybe that C-clip holds the spring so you can undo this nut if you want to without the spring coming undone. Not that that is a particularly useful thing to do. Right, that's that. Well, you may be wondering why I want to take the quill out anyway. And the reason for that is that when I first got this mill, I did some test mills with mild steel just to get the feel of it. And naturally enough, the end mill got hot when doing that. I thought nothing of it. But more recently I've been milling small pieces of aluminium to make this servo gearbox that I'm interested in. And I noticed after doing that that the end mill was cool, this was warm here, this was hot, and that was warm. So I realised, or thought, that maybe the bottom bearing in this spindle had failed or was about to fail. So I spoke to Warco about it, and they said, well, it might get a little bit warm, but it shouldn't get hot. If it's getting hot, probably the reason is there is too much preload on the taper roller bearings. And what you need to do is to loosen the nut at the top of the spindle. That was the words that they used. And my first thought was, well, do you mean this nut up here? But looking at it, obviously it wasn't that. It was more the case of loosening the collar at the top of this spindle here, at the top of the quill. So that's why I had to take that out. Now, I know nothing about mill spindles, but I do know something about Range Rover axles. This is the wheel hub of a Range Rover, which is supported by opposed taper roller bearings, and this whole assembly slides freely onto a stub axle like that, and then there's a nut that goes on this thread which you tighten up to establish a specified end float on the hub. So both of these bearings slide freely over the stub axle, and I kind of thought that if a mill spindle used taper roller bearings, it might operate on the same principle, except that perhaps you might do the nut up a little tighter to eliminate any end float. But as it turned out, in the case of the WM18 mill, I was wrong. So I've gripped the spindle in the vice jaws and the quill is free to rotate. So I'm going to loosen, is it loosen or undo these two screws? I think having done that, I should be able to, although this is the wrong size pins on the end of this, should be able to adjust this. Yes, right, so the question is how much looser should it be? I've moved it on. Well, if I undo it, I'll only go that far. Right, I think, let me just get this. So I'm covered in grease, this thing, which is a bit annoying. Well, it's useful, but I mean necessary. But okay, so there's still no. I mean, if I got this really loose, surely it would go up and down. Well, undoing it doesn't seem to make any difference. Let's see if we can take this out. Is this going to fall out? No, it can't fall out. Let's see what's underneath here. How would one ever know? Well, they're definitely bearing under there. And I'm not going to drop any dust down there. Well, the principle of this collar is that there's a slit here which is somewhere down in the thread. And if you put this M5 set screw in here and tighten it up, thereby bending this, it will push these threads together and hopefully jam the nut and prevent it turning. Well, looking at this again, I'm thinking that this bearing comes in from the top here. In my opinion, it shouldn't be pressed onto there, it should just be loose so that you can adjust the preload with this collar. But it seems to be extremely firmly sat there. That's the thread that the collar screws on. That's the inner race of the bearing. The ring in between the two there, I think, is part of the shaft. And then at the other end, right, so it looks as if the bottom bearing inner race is pressed onto this, which is the bottom of the spindle. That's the R8 taper. So even with both of the collars off, the one at the bottom and the one at the top, this thing is still completely rigid, which is bit odd because there's no actual real way of adjusting the preload. If the preload is in effect determined by pressing these bearings on, you might just as well, you know, take these collars off and the preload doesn't change at all. It still feels exactly the same. I have actually tried supporting the quill and bashing this gently with a wooden mallet. I didn't expect, if it were any kind of press fit, I wouldn't expect that to have any effect anyway, but it didn't shift. But my point is, if this is a press fit, this top bearing, then how the hell can you adjust the preload with these collars, which are doing nothing? Fact is, this thing is still stiff and rigid, not going anywhere, with both of the collars out. I was reluctant to apply more force because you know, you're not supposed to bash bearings across between the inner and outer race. So I didn't want to damage the thing without first talking to Warco. So I spoke to Warco and they said, well, we don't think this sounds right, but we've got a spare quill and spindle in stock, so would you like to swap it? So I thought, fine, that's great. I was very impressed that they had a spare in stock. So Warco is only about an hour's drive from me, so I zipped up there, collected the new spare and left them with my old one, and went back home and installed it, and it felt exactly the same in terms of ease of turning as the one I had before, and this one, the new one, also overheated at 2000 RPM. So I thought, I don't know what I'm going to do now. Well, I thought there's no point in taking this back to Warco because it's exactly the same as the one before. And up to this point in the whole saga, I still had not seen inside the quill and wasn't really clear what the internal structure of the thing was. So at this point I lost my temper and put the quill back on top of the vise and bashed it hard 6 times with my wooden mallet, and the spindle came out. So that was progress. I measured the internal diameter of the top bearing to be 29.97 millimeters, and I measured the OD of the shaft of the spindle to be 29.97 millimeters. So it was more or less an exact interference fit, something less than a press fit, but a great deal more tighter than a slip fit. Which explains why it will not go on and had to be hammered off. Well, my view is that this is wrong, but it may be by design. And I did wonder if I put this shaft in the lathe and just ran some emery paper, a loop of emery paper on there, whether I could take off a thou and make this fit a little bit easier. At this point I actually went back to Warco and spoke to their engineer, and between us we kind of came to the conclusion that possibly this interference fit is by design rather than a mistake. I mean, if you designed it at that top bearing as a slip fit, then manufacturing tolerances would be such that some slip fits would be looser than others. And if this is a spindle and this is a top bearing in a race, if there's, let's say, 1 thou slop there, that would translate to a similar movement below the bottom of the spindle. Whereas if you design it as an interference fit, then there's not going to be any slop at all. But the downside of it is that you have to be aware of that, and it causes problems adjusting the preload on the bearing. So whereas you could press the top bearing down onto the spindle almost fully home and then put that collar on and screw it down very slowly, adjusting it, testing the preload and the movement in the shaft until you got it exactly right, that would be fine. But if you overshot with the collar and drove the bearing down a bit further, the only way you can get it back is to bash it on the top with a mallet. Well, that's fine so long as you know that that's what you've got to do. Although it's something that an engineer wouldn't actually do, because you don't bash bearings like that. So I went home and decided to I actually decided on a slight compromise. I decided I would very slightly reduce the diameter of the spindle shaft, but not make it at all loose. Well, I can chuck this shaft in my Chinese mini lathe, but what I can't do is put a live centre on the end, because the thing is just too long, so I can't really do any machining, or certainly not in the middle of this shaft. But just for fun, I thought I'd try and see how close I can get it in terms of run out. So I've chucked this up in the 4-jaw, and the run out at the moment is well, I suppose it's 1.5 times 0.01 millimeters. So this is P150 emery cloth. We'll see if it makes any impact at all. I don't know whether this is a hardened shaft or not. I don't think it is. Oh yes, that's going to... Well, that has made a considerable improvement. So it is almost a slip fit now. And I think I'll quit while I'm ahead there. Because we don't want it to be loose, do we? So I think that's just toned it up enough to stop it being a pain in the arse. Well, I've got the inside of the quill nice and clean, and the races of those bearings seem to be okay. Well, now I'm going to grease the bearings. I got this extreme pressure grease from SKF, which is intended for this kind of thing, hopefully. So I'll use that. There is a video on YouTube from Robin Renzetti, where he spends a lot of time explaining how to refurbish mill spindles, and he is an expert on the matter, and he says he's designed hundreds of spindles, and he spent a lot of time training grease to stay inside the race of a ball bearing. He was talking about ball bearings rather than tapered bearings. Well, I'm not going to do that because it's too much bother and too difficult. I'm just going to get as much grease into these bearings as I can and hope for the best. So I put the spindle back in, and there's a collar on the bottom which I've done up as far as it will go, and all that is just a cap to stop dust going in. It doesn't actually engage with the bearing at all, which can still move up and down at the moment. And then we've got the top bearing in there, It's not fully down, but it's as far down as it will go, just pressing it gently. And this collar is screwed down to establish the preload, and I hope it will also be able to force the bearing further onto its seating. Right, so I've held the quill in the vice soft jaws, and we're going to adjust that collar. There's no spec for this preload, so I'm just going to adjust it by feel to be slightly looser than it was last time. Unfortunately, I don't have the right pin spanner for this. I'm just hoping that this is going to be strong enough to do it. We've still got quite a way to go. Teeny bit more. I don't think there's any up and down movement now. Question is that any less than it was before? I don't know. So hard to remember and to tell. There should be some kind of proper spec for this. This was what I was doing before. Well, if you want my opinion, then I think that's about the same as it was before, and we can't have it quite as much as that. So I'm going to loosen it off a bit. Like that. And of course that will have no effect because the way the bearing is loose. So now I'm going to do what nobody should do ever. Well, it feels remarkably similar to what it was before, and I'm going to install that and see if the bearing gets hot. I think the kind of shrieking sound at high RPM is the gears in here rather than the bearings. At least that's what I'm hoping. Well, it's still getting hot. So, what do we say? This spindle gets hot, it's designed to get hot, or do we take it out and ease it off a bit and try it again at the expense of having run out on here? I don't know. Well, the run out on that at the moment, that is assuming this thing is circular, is not more than 0.02 millimetres, probably more like 1.5, 0.15. 0.015. Well, I put a fatter end mill in there just to measure the run out on a tool rather than on this spindle face. .005mm, which is 0.2 thou. So that's kind of thing, that's all right. Well, I think I'll have a cup of tea and think about this. And then maybe come back after tea, take the quill out again, slightly slacken off that collar, bash the spindle on the top with a hammer, put it back in again and measure it again and see if it still gets hot. Well, just very slightly warm. That's perfectly okay. So now the question is, with this amount of preload, how much run out have we got? And you know what? I'm going to do that tomorrow because I need a drink and a rest. The trials and tribulations of machining. We haven't actually done any machining yet. We're fiddling at the moment.